All right, we're on review problem 467, where it asks us to calculate the percent composition by mass for each of the following. We'll start off with sodium dihydrogen phosphate. Sodium, we know what the phosphate is, PO4. Dihydrogen means it has two hydrogens with it. All right, so this is the dihydrogen phosphate ion. The PO4 is a 3- ion. With two hydrogens on it, though, it's just a 1- ion. So this compound, sodium forms a plus charge, is NaH2PO4. All right? And calculate the percentage composition by mass for each of the following. So we want to know what the percentage of sodium, hydrogen, phosphorus, and oxygen are. Okay? Well, sodium weighs 23 grams per mole. Hydrogen is, we'll say, roughly 1. Potassium, we'll say, potassium. Phosphorus, we'll say, is 30.31, and oxygen is 16. But here we have 2 hydrogen, so that's 2, and we have 4 oxygen, so that's 16, 32, 32, 64, right? 64. Now, we can add them all up and determine the molar mass, right? Molar mass. Sodium, 23, right? 23 plus 2. Oh, got to clear my calculator out. 23 plus 32. No, sorry. 23 plus 2 plus 31 plus 64. Adding all these up, that's a total of 120. Let's make sure we got that right. 1 sodium, 2 hydrogens, 1 phosphorus, 4 oxygen. 16 is 16, 32, 32 plus 32 is 64. So we have 120 grams altogether. So 23 divided by 120 grams per mole. So divided by 120, and that's 19.2% sodium. Hydrogen, 2 divided by 120. That's 1.6% hydrogen. Phosphorus, 31 divided by 120. That's 25.8% phosphorus. Oxygen, 64 divided by 120, 53.3% oxygen. All right. The next one is the ammonium dihydrogen phosphate ion. Ammonium dihydrogen phosphate. So this only changes by this being NH4+. So we have NH4+ coming together with the dihydrogen phosphate again. Dihydrogen phosphate, yep. So the only thing we have to change here is the fact that this is now an ammonium ion, 1 nitrogen, 14, and instead of 2 hydrogens we have an additional 4, so that's a total of 6 hydrogens, 4, 5, 6. So that's a total of mass of 6, all right? So we have 14, 6, 31, 64. 14 plus 6 plus 31 plus 64, and that's 115. Okay? So 14 divided by 115, that'll tell us 12.1% nitrogen. 6 divided by 115, that's 5.2%, 5.21%, or 22%. Hydrogen, 31 divided by 116, 26.7% phosphorus. 64 divided by 116, 55.2% oxygen. All right, let's just double check that one real quick. Make sure we're not missing something there. 467B, 12, 5.2, 25.6, and 55.6. So the phosphorus is slightly off because we rounded off in our numbers here. That's all right. Okay, so the next one we have CH3,2CO. Okay? This, you wouldn't know that, but this is the shape of that molecule. This is called acetone, all right? So CH3CO, okay? It's an organic molecule, has an oxygen here, mostly made of carbon and hydrogen though. Okay, and we want to know what mass of carbon, what percent is carbon. what percent is hydrogen and what percent is oxygen, right? So we have 3 carbons, that's 12 times 3, 36. 1, 2, 3, 6 hydrogens, that's 6, and 1 oxygen, that's 16, right? Okay, so we have 36 plus 16 plus 6. 58. 36 divided by 58, we're at 62% carbon. 6 divided by 58, 10% hydrogen. 16 divided by 58, 27.85 or 27.6% oxygen. And I didn't put down all the decimal places there, but you get the idea, right? Calcium sulfate dihydrate. Calcium sulfate dihydrate. Okay, let me check. Calcium sulfate dihydrate. Okay, so calcium, I think it's 40, isn't it? Sulfur, 32. Oops, yeah, 467 still. Sulfur, 32. Oxygen, 16, 16, 32, 64 for 4 oxygen. Oh, but there's 6 oxygen. So 64 plus 32, 96. Because there's 6 altogether. 6 oxygen. All right, and then we have 4 hydrogen at 4. 4 hydrogen, 4, 5, 6 oxygen, 1 sulfur, 1 calcium. So we got 4, 5, 6, 7. So 40 plus 32 plus 96 plus 4. 172. And that's how many grams there are per mole. That's all the mass due to these different atoms, right? So if we want just copper, we have to go 40 divided by 172. 23.3% calcium. Sorry, not copper, calcium. Sulfur, 32 divided by 172. That's 18.6% sulfur. 96 divided by 172. 55.8% oxygen. 4 divided by 172. That's hydrogen, 23.3% hydrogen. All right. Calcium sulfate dihydrate. Calcium sulfate dihydrate. Calcium sulfate dihydrate. The next thing is calcium sulfate dihydrate too. Are they trying to trick us? 467. Let's see what it says. Yeah, exact same values. Whoops. On this last one. Not 23, it's 2.33, right? Because gotta move the decimal place just twice, and it was 0.02. Okay? Very good. So, 469. Which has a higher percentage of oxygen? Morphine, C7H19NO3, or heroin? C17H19O3 or H19NO3, or heroin, C21H23 NO5. All right, so we have to add these all together. We got 12 times 17 plus, so that's 12 carbons times 17, plus 1 times 19, plus, there's 114 for the nitrogen, plus 16, 16, 32, plus 16 is 46. So I'm getting 283 grams for every mole of this stuff here. And if there's 46 divided by 283, then I'm getting 16.3% oxygen for this top one. All right, here we go again. Carbon is 12 times 21 equals plus 23 equals plus 14. 23 because there's 23 hydrogens and each hydrogen weighs 1. 14 because there's one nitrogen and each nitrogen weighs 14. Plus 16 times 5, right? So I'm getting, whoops. 369 grams per mole here, but there's 80. The mass of 80 is due to oxygen, right? 16 times 5 is 80. So we got 369, or 80 divided by 369 equals 21.7%. So heroin, second one? What is it? Heroin, yeah. Heroin has a higher percent of oxygen. 471. Freon is a trade name for a group of gaseous compounds once used as propellants in aerosol cans, which has a higher percentage of chlorine. Freon 12 or Freon 14. Let's say Freon 12 or Freon 14. Freon 113. No, Freon 141b. So 471. Freon 12, CCl2F2. CCl2F2. And the other one is C2H3Cl2F. C2H3Cl2F. Right? C2Cl3. Wait a second. C2H3Cl2F. CCl2F2. Okay. Which has the higher concentration of, higher percentage of chlorine, right? Okay, higher percentage of chlorine. So we have chlorine is 35.45, so you have 35.5 about, times 2, there's 2 chlorines there, plus the 12. Fluorine is 19. Alright, so 83 plus 19 plus 19. So this is a mass of 121 grams per mole. And if we take our chlorine, 35.5 times 2 divided by our 121, this is 58.7% chlorine. The first one. Our second one, this is 24 here, this is 3, this is 35.5, which is 71, because there's 2 of them, plus 19. So we got 24 plus 3 plus 71 plus 19. And then we have, that's 117, so we go 71 divided by 117, and that's 60.6, or 60.7%. So the second one has the higher percentage chlorine. That was 471. 473. It was found that 2.35 grams of a compound of phosphorus and chlorine contain 0.539 grams of phosphorus. So we have an initial sample, 2.35 grams. 2.35 grams of PXCLY. We don't know the ratios there. There's a compound that contains phosphorus and chlorine. We'll draw ourselves a little picture so we can kind of visualize what's going on. So here's some compound, 2.35 grams of it contains phosphorus and chlorine. And 0.539 grams of that was phosphorus. So 0.539 of these grams were due to phosphorus. And all of it was due to phosphorus or chlorine. So we know how much was due to chlorine by there's difference, right? What are the percentages of mass of phosphorus and chlorine in this compound? Well, phosphorus is 0.539 divided by 2.35, right? So that's 23, about 22.9% phosphorus. Chlorine is going to be our 2.35 minus our 0.539, and that's 1.811 grams that are due to chlorine, right? And then we take 1.811 divided by our total mass again, 2.35, and that gives us 77.1% chlorine. All right, there's 473. Phenylcyclidine. Phenylcyclidine, 475, Angel does, is C17H25N. A sample suspected of being this illicit drug was found to have a percentage of 84.71% carbon, 10.42% hydrogen, and 5.6% 1% nitrogen. Okay. Do these data acceptably match the theoretical data for Phenylcyclidine? All right. All right. So let's see. Well, we just have to find out the mass of this, and find out what percentages they are, and see if it matches. Okay. So we got 12 times 17 here, right? That's how many, the mass due to carbon, that's 204. There's 204 grams due to the carbon for every mole. 25 grams due to hydrogen here, and then 14 due to the nitrogen, right? So I'm getting a total of 243 grams for every mole. 243 grams of this stuff for every mole. So we take our 204 divided by 243, and we get 83 point, so it's 84.0 if we round it up. 84.0% carbon, 25 divided by 243, 10.3% hydrogen, 14 divided by 243, 5.76% nitrogen. That's pretty close, I would say. Definitely yes, especially because we didn't use very precise numbers here, so we can give ourselves a little bit of wiggle room. We'll just double check here, see what they said, 475 in the back. These data are consistent with the experiment values cited in the problem, so that means they are consistent. That's a good answer, because obviously, if you were the one on trial for having that, you'd say, wait a second, I want a little more accuracy there, right? And you'd have to get in statistics to make sure that your lawyer could disprove that you were guilty, right? All right, how many grams of oxygen? 477. 477. How many grams of oxygen are combined with 7.14 times 10 to the 21 atoms of nitrogen in the compound dinitrogen pentoxide? How many grams of oxygen, so we're looking for grams of oxygen, are combined with 7.14 times 10 to the 21. 7.14 times 10 to the 21. All right, and this is atoms of nitrogen. All right. Well, we just need to get this to moles because we know the mole ratio here, and then we can get to grams of oxygen. So if this is 7.14 times 10 to the 21, there's 6.02 times 10 to the 23rd atoms of nitrogen for every 1 mole of nitrogen, right? Now we're in moles of nitrogen, and there's 2 moles of nitrogen for every 5 moles of oxygen. And for every 1 mole of oxygen, there are 16 grams of oxygen. All right, so we got 7.14 times 10 to the 21 divided by 6.02 times 10 to the 23rd times 5 divided by 2 times 16. So I'm getting 0.474 grams of oxygen. That's 477.